there, please mute yourself. Shivraj, can you please mute?
Okay, sir.
Shivraj, please mute so that there's no disturbance. Okay, and when you have to say something, you can always unmute and say. All right, good. Okay, so let's start. So binary numbers, all of us know binary numbers, and binary numbers are important because the entire processing of the instructions, the way data is stored, everything happens in binary. So binary is basically the machine language. Okay, the machine language. So the language that machine understands is in the form of binary. So binary numbers are nothing but this is another format in which numbers are represented. Okay, you have decimal formats. In the decimal format, you have numbers from 0 to 9, and you represent any number using 0 to 9. In case of binary, you represent any numbers using 0 to 1. Okay, so even the largest of numbers you can represent using 0 and 1. Now, when we look at the storage inside a computer, right, when we look at, for example, a char, right? Now, char is a data type, we all know. And what is this data type? It is a data type which basically stores a character. So, an example of character is A,
Uh,
right? An example of character can also be A. But if you have combinations like A, B, C, then this is not a character, but this is a combination of three characters, and we call it string. All right. Now, an object of the char data type represents a single character. Now, for example, A is a character, but 7 is a number, right? All of us know that. However, the computer cannot store A. That means when the computer is storing things inside the memory, it will not be able to store A. Okay, so if you have any characters like A, X, B, right? They all have a very unique code. They have a very unique number because the computer is not able to store these characters directly. Computer will not be able to store ABC. Computer has to convert it into some kind of number. Okay, and it will be storing basically the all the numbers, characters, everything will be stored in the form of binary. So because the computer cannot store these A, B, C, D, X, Y, Z, all these different kind of characters, these are all characters, all multiplication, plus, division, all these are different kinds of characters. There is a numeric code associated with all this. Okay. Now, these are called as ASCII codes. Anybody knows what is ASCII? ASCII stands for American Standard Code for
Information interchange.
Information Interchange. Very good.
interchange. Interchange.
Interchange. That's it. So, what exactly is this American Standard Code for Information Interchange? Okay, now this is a standard. This is a standard which represents a character set. So if you look at these character sets, A1, number 1, 2, 3, I mean, all the character sets which you have is basically assigned a number, and that number is the standard code. That means anyone who understands computer, anyone who is doing programming, anyone who has knowledge of computer will know this standard code. That means why there is a need for a standard code? It's because suppose for A, if you designate your own code as 20, if I designate the same code as 30, and somebody else, some other programmer says that no, I will put it as 40. So what will happen is this will cause a lot of confusion, because everybody will start putting their own code. So what they did was they got a standard out. That means whoever uses the code, they have to use the same value. So there is this American Standard Code for Information Interchange. It is called as ASCII in common. So they devised a standard code which has got the unique number for each of the characters. So now when the character is stored, right? So that number is converted into a binary number and then it is stored. So let's look at a character in little bit more details. So how do you define a character? So suppose I have a character. Now this is a keyword. That means it tells you that the variable, so you can give a name to this character. So I can say gender, right? So gender is the name given to a data, right? It's a container, name of the container. What is the type of this container? The type is character, which we call it as data type. So I can define something here. I can put some value into this, right? So I can put a value M. Are you able to understand this? I can also have a character like my cap. So these are all user defined names. These are all user defined names and they are called as variables. And this is called as constant and this is called as data type. So you know that because I have taught you in the previous class that this is a variable, right? This is a data type and this is a constant. Okay, so say I have another variable called my care and inside this I am putting a. So what is this a? It's a data. What kind of data it is? Character. Where is this data stored? Into a variable called as my care. Okay, so when we are declaring, right, we can declare even something like this. I can say declare x, y, and z. That means I have defined 3 containers. These containers are going to store what? They are going to store data. What is the data? What kind of data? They're going to store the kind of data which is char. Okay, and then I can initialize the data inside them. So what I can do is I can say in x put the data a, in y put the data f, and in z put the data 7. Now this 7 here is not an integer because I have put it inside this single quotes. It represents a character. Okay, so what is this 7? So 7 represents that character. In the ASCII code, you have for each characters there is a number in the ASCII code. Okay, for each character there is a number associated 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7 represents that character for which the number is 7. Okay, so we will see exactly how to go about this. All right, now this is called as a character constant. Okay, so don't get too confused about it. Okay, we will look into it in more details. Now, when we had seen the first program in C, right, we had come across this one. Do you remember this? We had come across, so using printf, when we used printf, right, we came across this particular symbol. How many of you remember this? And I had told you that this is used for printing to a next line. Do you remember this?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay, great. Now, one thing you must remember is this slash, okay, is called as an escape, ESCA, escape character. Okay, the slash is called as escape character. So this is a character. So slash, this slash that you see here. Okay, this slash that you see here, this is also a character. This is called as escape character. So for this, there must be some number associated in the ASCII character set. Okay, so as soon as the computer sees this, right, it knows that the next character n, okay, will cause a sequence. That means it will do something. That means it will leave that entire line and then go to the next line. So this slash that you see in this n is also a character. This is called as escape character. Okay, we'll be using a lot of these characters. So for example, there are other characters like slash b, slash f, slash r, /t. Okay, so we will look into this later when we actually use it in the programs. But for now, just remember that this slash is also a special character. Okay, now you already know how to use printf, right? You already know how to use printf. So printf, you have already used it before, right? So now I'm going to write a small program and let's see whether you are able to understand what we are trying to do here. So let me know if you are not able to follow anything, okay? And also if you are not able to see my screen. So let's write a small program. Okay, we will cover more details about this stdio.h, but I have given you a rough understanding of what this means, and what this means, right? So this part we will cover, this stdio.h we will cover in more details. Okay, but for now, I think you will be able to understand what I'm writing here. So here is my main. I can write int as well here. Now inside this main function, here is a character, okay, and there is another character C. Now what I'm doing is C1, I'm assigning the value A, and in C2, I'm assigning small a. Now, A and small a are two different characters. Okay, they are different characters because they are represented by two different numbers. Just remember that. Now, I'm going to use a printf. So, if anyone is not able to understand, you can let me know. But I think this is pretty much clear. Now, this is something which I am doing for the first time here. This is something which I have not explained it to you, but I will explain it to you now in some time. But let me finish writing this. Okay. All of you also, all of you please make a note of this in case. So again, I'm writing this percentage %C, putting a dot, and C2. I think this should be fine. And let's return 0 and this. Okay, fine. So what do you think will be the output here? Guess, just take a guess. Just take a guess.
So the it will print the character. It will convert the int to character.
No, it will not put. There is no int here. There is no int at all.
No, the percentage C.
Sir, it will change the case, uppercase to lowercase.
Uppercase. No, not at all. So what is
Sir,
what we? Yeah.
output is modular C.
Output is
Modular C.
modular C.
Yes, sir.
No. Okay, the output of this program will be. Let me write it. The output of this program will be A and A. Same thing that you wrote here. Okay, there is no difference here. Whatever we had given here, the same thing will be output. Now let me explain to you why. Okay, now here comes a very important concept, and this, if you see here, this is an important thing that I need to explain it to you, that we need to understand. Okay, so everybody is there. Now this is called as format specifier. Format specifier. All right. Now, what does the format specifier tell you? What is this percentage %C? So this is a special kind of instruction. It is a special kind of instruction which tells the computer that the contents which are contained by C1 and C2, okay, C1 is basically A and C2 is basically this small a. So I am trying to print C1 and I'm trying to print C2, the value of C1 and the value of C2. Now this is going to tell me, it's going to tell the computer in which format you should print these two. Okay, so these are called as format specifiers. Now in this case, when you say %C, okay, this is an instruction to the computer that the format in which these two should be printed is character format. Okay, in character format. So what we have entered? We have entered A and A. So what is the character format of this? The character format of this is A and A. No change. So what is printed? Because we have specified here that printed in the character format and what we have entered is character, so it will print A and A. Did you understand this?
Yes, sir.
So this
Yes,
is
sir.
basically a format in which the values of this need to get printed. Now I'm going to change this program a little bit. Okay, now I'm going to change this format a little bit. So just look at the changes that I'm doing here. Now what I'm doing here is a small change. Okay, let me remove all of this. And now I'm going to write in place of C1, I'm going to write 65. And then in place of C2, I'm going to write 97. And now I am going to have this same program. Now can anyone guess what would be the output here?
Sir, error.
Error?
Yes, sir. No, and not output.
No output? Why do you think there will be an error?
Sir,
So
because it
even
is a integer,
Because
not a
I'm
character.
putting here, because this is an integer, that's what you say, right?
Yes, sir.
Okay. Now, the output of this is going to be this. I'll explain to you how. Okay, so
So the
remember that
ASCII character.
Sir, it
the
is the
out,
ASCII value now.
absolutely. So the output of this is going to be A and A itself. Why? Because 65 is the ASCII code for A and 97 is the ASCII code for small a. So since we are entering the ASCII code here, but our format specifier tells us that print it in the character format, not in this format, print it in the character format. So what is the corresponding character of 65 in ASCII format? A. What is the corresponding format of 97 in the character format? It is A. Did you understand this?
Yes, sir.
yes, sir.
Okay,
Yes, sir.
everybody
Yes, sir.
understood?
Yes, sir.
Yes, sir.
Okay. Okay. Now I have to tell you a small simple concept. Okay. See, we can finish everything in one day, but I'm telling you those minute small concepts which are important for you. First important thing. How is 65 being stored in C1? Okay, that is an important question. How is 65 being stored in C1? Now, whenever we declare any variable, like in this case, suppose we are declaring a variable C1. Okay, now C1 is what? It's a container. Okay, it's a container. So I'm just going to clear this. So let's say I am writing character C1 is equal to 5. Okay, now in this case, C1 is the container which is of type char, and this value 5 is being stored inside this container. Okay, now important thing, every data type, whether it's a char, whether it's an int, whether it's a float or a double, has got a specific size. That means the size of the container is fixed, and that size depends upon the compiler that you are using. Okay, so different compilers have different sizes, but most probably in most of the compilers, the size of the character is 1 byte. Do you know what is 1 byte? Do you know what is 1 byte?
Um,
8-bit.
30 to 32 bit.
Okay, so
8 bits.
so difference between byte and bit. Okay, what is the difference between byte and bit? These are very fundamental concepts, and you must know it very well. Okay, now 1 bit is the memory. 1 bit is the memory space which can store one binary digit. Okay, did you understand that? So suppose I have one binary, 0 and 1. Okay, so the amount of space that you need to store one digit, one binary digit, for example 1, can be called as a bit. So bit is that one small unit, the micro, it's like the molecule of storage. Okay, it's like the molecule of storage. So you can have 1 bit. So if you have 1 bit, how many numbers? So binary, you have 0 and 1, right? So what is the combination of numbers that you can store?
1 or 0.
So you can either store 1, because if you store 0, then the space is occupied. You can't store another number. Shivraj, please. Yeah, thank you. So if you put 0 there, you can't store 1. If you have 1, you can't store any other digit. So if you have a space which is of 1 bit, you can store 0 and 1. That means you can represent only two numbers. You can represent 0 or you can represent 1. So what is the range of values that you can put inside that? 0 or 1. That's all. So imagine if I increase the bit to 2. Now I have 2 bits. Now I have 2 bits. So what is the number I can store? So I can say 0. So what is the number I stored? 0. Now, if I write 0, 1 in, this is in binary. So what will be the value? 1. Now, can I store 1 and 0?
1.
1 and 0? Yes. So if I store 1 and 0, so the combination will be 0, 0, 0, 1, 1, 0, and 1, 1. These are the 4 combinations possible. Yes. So
Yes,
in the binary format, this is 0, this number represents 1, this represents 2, and this represents 3.
3.
Okay. So if I have 2 bits of memory, then I can store the range of values between 0 to 3. Okay. So let's say if I have 3. So if I have 3, what is the range I can use? What is the range of values that I can use? So I can have 0, 0, 0, then I can have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. These are the combination of digits I can use. This represents 0, this represents 1, this represents 2, this
0
represents
to
3,
7.
4, 5, 6, 7. Okay, so I can represent value from 0 to 7. Do you understand what I'm doing here, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes? Okay,
Yes, sir.
Yes, sir.
very good. So there is a formula. There is a formula for calculating how much of values you can store in the different number of bits. So if you look at this generalized formula, it is 2 to the power n minus 1. That means if your bit is, if the memory is 1 bit, then 2 to the power 1 minus 1 this becomes how much? 1. Understood? So if I have just one bit, I can store only 0 and 1. That means I can store only 1. 0 is common everywhere. So if I have if the bit size increases to 2, so I have 2 to the power 2 minus 1, which is equal to
3.
3. So here, look at this 3. Okay, so if I increase it to 3, then what is the bit size? Total, what is the value which can be stored from 0 to
7.
7? Look at here, 7 comes here. Understand? So if I have 4, then what is the value?
15.
15. Very good. Okay. So if I have 2 to the power 8, can anyone calculate and tell
63.
me? How much?
63. 63.
2 into 2 into 2 into 2, 2 to the 4 to the 8 to the 16, 16 to the 32, 32 to the 64 into
0 to
2,
255.
255, right? 255. All right. So 2 to the power 8 means I can represent values from 0 to 255. Are you all able to understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Which means all the values that I'm representing is positive values from 0 to 255. Yes.
Yes, sir.
Yes, sir.
But if I
No,
want
sir.
to, if I want to, now how many actually values are there from 0 to 255? Okay, fine. Now, what I can do is I can even represent negative values. So if I represent negative values, then my range will decrease. Then my range will be minus 128 to 0 to
0.
127.
250.
Now
Yes, sir.
total here, how many numbers were there? 255. Here also how many?
255.
255. Understood? So if I have 8 bits of storage, that means I can represent numbers, values from minus 128 to plus 127. But if I don't want to represent minus, then I can represent from 0 to 255. Did you understand these concepts?
Yes, sir.
Yes, sir.
Yes, sir.
Perfect. Very good.
Yes,
Very
sir.
good. So
Yes, sir.
if I have 16 bits, you can calculate this and this. Yes.
Yes, sir.
Yes,
If I
sir.
have
Yes.
if I have 32 bits, then you can calculate this and this. So it's
Yes,
very
sir.
simple. 2 to the power n minus 1. Remember that. So this is how values are decided in the different data types. Now, when you talk about char is a data type whose container is made up of 1 byte. Okay, the 1 byte is equal to 8 bits. Did you understand? Which means it can hold 2 to the power n minus 1 values, which was equal to 255 or minus 128 to 127 values. Okay, so I can represent numbers. So in the previous example, right, when I gave you that example, I had written C1 is equal to 65 and C2 is equal to 97. The 65 and 97 are in this range. Is it there in this range?
Yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
That means these values are being accepted. These values will be accepted. But if I try to put a value which is not in this range, then my problem will start. So if I write C1 is equal to 500, there will be an issue. If I write C1 is equal to 300, there will be a problem. Did you all understand?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So just remember that for now, and then we will be getting into this little later. So that time things will become more and more clear. So every data type has got a size. Character has got 1 byte. Int has got, it's basically, 4 bytes, okay? Now this depends on the compiler. This depends on the compiler, but in general, your integer will be of 4 bytes. When we talk about 4 bytes, then if I ask you if it is a 4 byte, then what will be the total values that can be stored inside this particular integer? Then how will you calculate? Okay, 4 bytes. 1 byte is equal to
8 bit.
8 bits.
8 bit.
8
So
bits.
0 to 2 to the
So
power of
Yes.
32 minus 1.
4 byte is 32
That
bits.
2 minus.
So
Yes.
in order to find 32 to the power, sorry, 2 to the power 32 minus 1, right? 2 to the power 32 minus 1. So it's 2 to the power 32 minus 1. So this will be the range. So if you calculate, it will be somewhere around, minus 21474836482 plus 21474836487. You can easily calculate this. You don't have to do it, but this is the process of how the range of the data types is calculated. Did you understand?
Yes, sir.
So if your compiler is giving you, if your operating system is saying that it is 8 bit, it is 32 bit, that means you know exactly what they are talking about. You know when an operating system says that I am a 32 bit operating system or I am a 62 bit operating system, which means that it can handle large amount of data. So if it is, say, if the integer is not 4 bytes, but it is 2 bytes, then actually it is made up of 16 bits. If it is 16 bits, then you have to do 2 to the power 16 minus 1, which will be equivalent to around, minus 32768 to 32767. So look at this range. I think somebody's microphone is still on. Please unmute yourself. Yeah, thank you. So if you look at it, 16 bit to 32 bit, okay, if I change from 16 bit to 32 bit, look at the range in which it is changing. Look at the range is expanding. Here there is only a 5-digit number, but look at here, what is the range? So if I increase the size of my data type, so if there is a compiler, suppose an old compiler, if an old compiler allows you to store 2 bytes into an integer, that means the range of values it can handle is only this much, 32,768 to this. But if the compiler is giving you 4 bytes to store an integer, that means the range of values is so huge. Okay, so depending upon the compiler, the maximum value that you can store is this. Now if I want that, I don't want to use any negative, I want only positive value. So what will happen? This will become double. That means your range will start from 0 and double plus 1. Okay, so this will become some 64,000 something, and this will become some, 4 lakh something, a huge number. Okay, it will be a huge number. So let's not get into the number thing. But basically, do you understand the concepts of
Yes,
what
sir.
I'm telling you? Okay,
Yes,
that's
sir.
more important.
Yes, sir.
Okay, that's more important. So remember that the size of data type and how the values are stored inside them is dependent on your compiler, and what is the size that the compiler is basically providing you with. Okay, now if you look at some compilers like Visual C++, okay, those old version of Visual C++, for example, those which are very old version 1.5, they provided integer of only 16 bit. But the latest version of Visual C++, actually after 5.0, Visual C++ compiler, they started supporting 32 bit of integers. Okay, so everything is compiler dependent. So don't always say that always the size of an integer is 4 or 2 or 3. It is all compiler dependent, but it's either 4 bytes, or 2 bytes or 8 bytes, whatever it is. It depends on the compiler. So you have to know which compiler you're using and what is the specification of the compiler you have in order to know what is the storage capacity that that compiler provides you. Okay, so I think this is more or less simple. So when we talk about an integer, again, it's the same way, right? Suppose you have an integer, so this is a data type. It's a type of data which has this age is a container, and the value that you put is an integer here. So in this case, this is an integer. All right. So same way, the declaration of character and the declaration of an integer is more or less same. So you can also declare an integer in the same way as we had declared a character. Like if I have int a comma b comma c comma d, or I can also have a small a, right? Small a and capital A are different. Okay, remember that. So I can say a is equal
Excuse me,
to,
sir. Sir, just a query.
yes,
Sir, sir, as we know, percentage is format specifier for integers.
yes.
So can
I
we declare can we declare the variables like d small d, because it's already a format specifier?
No, small d format specifier is when you put a percentage. Without
Okay,
percentage, this is d is not an
just an
access, is not a format specifier, but
okay,
percentage
okay,
d is a format specifier. Okay.
okay,
So
sir.
if you
Thank you,
don't
sir.
put percentage, then it is not. So
Then
you
it's a
can,
normal.
yeah, then it's normal. So you can have a as minus 37, a as plus 37. You can have b as a huge number 2418, and you can have c as 12. So this is how you can define your integers. Okay. So I think this is fine. Now important thing is, how in case of character, if you want to print a character, right? If you want to print a character, then you use percentage %c. What does it do? It will help you to output. The format of the output will be in the form of a character. So percentage %c is a format specifier for character. But if you want to output an integer, then the format specifier for an integer is percentage %d. Okay, remember that. It is, you can also do percentage %i. Both of them are equivalent. So percentage %i or percentage %d, both can be taken as the format specifier for your what you call integers.
Integers.
Okay, okay, both percentage %i and percentage %d, but most commonly we use percentage %d. All right. Now, what I'm going to do is I'm going to show you the same program. Okay. I have deleted it, so I should have kept it. My mistake, but anyway, I need to write it. So let me write it. Okay. Just you guys can just make a note of the same program, and then I will show you how the differences come out. So I'm not writing hash include and all the details. Okay, you know what is goes here. So I'm just starting from main. So I still have my character which has C1, and I still have my character which has C2, right? And I'm doing C1 is equal to A. What was the ASCII value of this? Do you remember? 65.
65.
Perfect. And I'm, yeah,
65.
very good. And I'm doing C2 is equal to small a. What is the ASCII value of this?
97.
97. Yeah,
97.
we will just remember this, okay? This is just for the sake of remembering. Okay, next. Now look what I'm doing here. Now I've used printf, okay? So I'm just writing value of C1, okay, let that be, is equal to, now I'm using percentage %d. Earlier I had used percentage %c. I'm using percentage %d and I'm writing C1. And similarly, I'm writing printf and value of C2 is equal to percentage %d. Please note this. This is important. Please note this. I have written different format specifier now. Okay. And /n comma C1. And I'm going to return 0. Okay. Now in this case, can you tell me
Sir,
what will be the
sir
output?
C1 or C2?
C1 and C2.
No,
What
no,
will be the
sir.
output?
The lower part you have written, sir, printf, the value of C2
Okay, okay,
percent
okay.
D, percent D. Okay.
Yeah, my mistake. C2.
Uh,
Okay. Okay. So what do you think is going to be the output here?
so 65 and 97, maybe. Cause
Very
the
good.
percent D.
Very good. Very good. Everybody, did you understand this?
Yes, sir.
I'm asking all
It is
the
the
others.
worst.
Yes, sir. Yes, sir.
Okay. Now, what happened here was, I am storing character A. What is the integer value of character A? 65 and 97. So here, the format is given that give me the integer value. I don't want the character. I don't want the character value. What is the character value? Character value is A. What is the character value? A. But what I'm asking is the number value, right? So the format specifier which I've specified is give me the integer value, give me the number representation of this character. So what it is going to print is 65 and 95. In case I change this to C and C, what will be the output? My output will be changed to A and A. Correct? So
Yes, sir.
in
Yes, sir.
case, now see, if I change here 65 and 97, my output will still be A and A because this is the value, integer value, but I want the character. It's saying the format in which the output should come should be the character format. So what is the character format of these values? A and A. Okay. So, but in case I change it to E and D, now what will be the output? The output will change to 65 and 97. Did you all understand?
Yes, sir.
Anyone has a doubt
Yes,
here?
sir.
Anyone has a doubt?
Yes, sir.
No, sir.
No?
Yes, sir.
Okay. Now these small things are very, very important. So
Yes.
you must remember. Now similarly, yeah. Okay. Fine. So remember what is important with your data types is the size. Okay. What is important with the data type is your size. Now that is most important. Size of your data type, and depending on the size, you can actually use the range of data in your program. Now we have another what you call data type, which is called as float, right? Let's just quickly look at float. Normally the float, you have a floating point numbers, right? In a float is another data type. Like unlike integer, it stores a decimal number. So for example, 7.01. Okay, or 5.71 or 3.142. Okay, now these kind of numbers is also called as real numbers. In maths, you will know it that it is called as a real number. Okay, now if you are specifying a float, right, you have to actually declare it in a different way. So I'm going to just write it. So I'm going to say that here is a float and here is, let's say, price. So price can be a good float number. So price is what? It's a container. What kind of container? A float, a container which is of type float. What is the value that is going inside that container? That value is, say, 5.71. Now when you are declaring a float, you have to write in at the end of it f, or you can write the same thing as 5.71f. Okay, remember this. So integers can be directly written 34, but in case of float, when you are declaring a float variable, when you are putting the values, you have to write the letter F. So you can write either small or you can write a capital F. That means this value is a float. Did you understand? Okay. Now
Yes, sir.
Got it, sir.
Yes, sir.
Yes, sir.
I will tell you why we have to write F. Now, in most of the cases, the floating point number is represented by, or the storage space is given by 32 bits. Okay, 32 bits means how many bytes?
4 byte.
4 bytes, right? Okay,
4
4
bars, sir.
bytes. All right. Now, if you have, a floating point has got another complexity. The complexity is that you have two different parts. You have two different parts. One is this whole number, and the other one is the decimal part. Okay. So, floating point, the precision of floating point, or basically how accurate or what is the range of floating point, is defined by this number of places after decimal. More the number of places after decimal, the more precision there is. Okay, so if I write 7.01, that can, this is also correct, and we can write 7.01036549. Which one has more precision? Which one is more accurate?
The second one.
Second one, right? So the number of decimal places, the number of places after decimal defines your precision. Okay, so if there is a 32-bit number, if there is a 32-bit storage for a float, then the maximum precision to which you can go is 6 places after decimal. Okay, so if your floating point has got 4 bytes of storage, that means you can write 1, 2, 3, 4, 5, 6. You can go up till 6. But if you want precision more than 6 places of decimal, then you cannot use float. That means if I want 8, 9, 3, 2, if I want 10 places of decimal, then float cannot be used. Okay, so what I need another storage container which gives me space of more than 32 bits. In fact, double of 32 bits. So I want a 62-bit storage container. 64 bits, sorry. 64 bit is how many bytes? 8 bytes.
8 bytes.
So if float is 4 bytes, then I need another container to store the same kind of number. So the problem, if you have noticed, character is a relatively simple data type. Integer is another simple data type. But when I talk about float and another one double, these are the same kind because they store a real number. But how are they different? Float can store real number up to 6 places of decimal. Okay, so if I want to store a real number which is more than 6 places, then I need to double the storage space. So for that reason, I have another data type which is called as double. So what this double does is it will give me a double storage space compared to float. So if the float is 4 bytes, double will give me 8 bytes. Now, what is the benefit of this? The benefit of this is I can store more number of values after decimal places. That means for higher precision, what we use a double. But if we want a real number with a lower precision, then we will use a float. Did you understand?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So now the important thing here is when we are suppose doing some calculation, right? Suppose we are doing some calculation. So suppose I have float as answer, okay? And if I'm doing answer is equal to 5.64 into 35, right? 356.8, something like this. Now, although this is a floating point number and this is also a floating point number, but what will the product? The product may become a double, isn't it? Because once you do the multiplication, maybe the precision will, increase. Or for example, say 22 by 7, right? 22 by 7. Now 22 by 7, if you do the division, this is a continuous thing. It can go 3.142, blah, blah, blah. So many things it can go. It can go to a large number. So when we are doing any kind of operations on any floating point number, so if you write 3.5 into 3.896, then automatically what the computer does is, what the compiler does is, because there is a chance that the product of this will exceed the storage that is allotted for float, then what the computer does is automatically it converts both these numbers into double, just to make sure that we do not kind of truncate the values, or we get enough space. But if you don't want to make this into a double, then what you have to do is I need to write f and f here. That means I am multiplying two floating point numbers, and whatever is the result of this is also a floating point number, which will be stored into the answer. So for that, I need to specify f. But if I don't specify f, by default, my computer or my compiler will convert it into a double. That is why whenever we are basically initializing a value to a float variable, I have to initialize it. I have to use f or f as suffix. Okay, so 3.14f is a float, and 3.143 is a double by default. Did you understand this?
Yes, sir.
Okay, perfect. Now I'm just going to take 1 minute. Oh, I think we already crossed. So, but I'll just tell you one thing. The access specifier for float is %f. Okay, just remember that the access specifier for float is %f.
F.
All right. I think we will continue this in the next class. But
Sir, just a question.
yes.
Sir, ये जो let's suppose I'm declaring a number 3.14, but I'm using format specifier %f. Still, it will gonna be converted to double, or for float I have to mention the particular f after that.
No, if you have written it as 3.14, and if you're using %f, it will be showing it in float. See, the output is the same. Output does not. So if you have 3.14, output only to two places of decimal. Output for double and for float is both the same, isn't it?
Okay, sir. Okay,
The
sir.
output doesn't change. Output doesn't change because 3.14 is a floating point number also, and 3.14 can be a double also. So output, there is no change. There is no change between the output of float and double. But yes, if you use float, then what will happen is it will give you something like this, 6 places of decimal.
Okay. Okay, sir. Sir, just another question, last one, sir.
Yes.
Sir, let's suppose I'm declaring a variable which size is 2 bit. लेकिन सर जो मैं कंटेनर यूज किया हूँ, मतलब लेट्स सपोज मैं उसके लिए फ्लोट यूज कर रहा हूँ, तो वो मे बी 8 बिट रहा कि जो भी ज्यादा स्पेस रहा, तो वो जो छोटा
there will be a problem. It's like तुमने एक छोटा सा कंटेनर डिफाइन किया है, पर इसमें एक बड़ा प्रॉब्लम डाल रहे हो, डेटा बड़ा है ना?
नहीं सर, मैं बोल रहा हूँ सर बड़ा साइज है लेकिन छोटा वेरिएबल अगर डाल रहा हूँ, तो जो रेस्ट जगह नहीं, तो सर फिलअप हुआ, तो जो रेस्ट जगह रहा उसको क्या फिर दूसरे बार हम यूज कर सकते हैं ना? वो वही वेरिएबल में वो ऑक्यूपाइड हो जाएगा एक्स्ट्रा जीरो लगाकर?
वो यूज नहीं कर सकते, वो तुम्हारा वेस्ट हो गया।
ओके सर, सो इसलिए मोर एफिशिएंट करने के लिए सर मतलब यूज करते हैं।
Yes, so that's why the size is important.
Okay. Yes, sir, one question.
Something? Yes.
Yes, sir, one question. सर हम लोग को बड़ा
Yes,
कंटेनर
please.
लेके छोटा, सर बड़ा कंटेनर लेके छोटा साइज देंगे
Hmm.
तो सर वो साइज
Tell
मेरा
me.
खाली रहेगा या फिर वो ऑक्युपाइड दूसरा से हो
Okay.
जाएगा सर?
So if I take a big container and I put a small value, okay, so say
Yes,
my
sir.
container is big, but my value is small. So let's say I have a big bucket. This is my bucket, and here is one small glass of water. Okay,
Yes, sir.
so I am
Yes, sir.
pouring this into this big bucket. So what will
Yes, sir.
happen? This much of
Sir.
water will be filled, and the remaining will be empty.
Yes, sir.
No problem. There is no problem. Only thing is this much of space is wasted.
Yes, sir.
Okay. But if you do
Okay,
the
sir.
reverse, if you take a small container, but if you have a big bucket and this bucket is full of water, now if you pour, what will happen? This will get filled off and all the water will go all over the place.
Yes, sir.
Isn't it? So if your value here was 100, right, out of which
Yes.
many will flow, overflow, and there will be something which will be left here. Something will be left here. But this will not match with this because half of the data is already spilled. Are you able
Okay,
to
sir.
understand?
Okay,
Okay,
sir.
so I
Yes.
will explain this in one class. Don't worry about this because this is called as, when we are learning a concept called as casting, I will tell you exactly what will happen there. So for now, you don't need to remember anything. You don't need to worry about it anything. Okay, so we will cover all of this in the classes which are coming ahead in future. So I hope everybody has understood what we have done today, and
Yes,
tomorrow
sir.
we will continue. Okay, fine.
Okay,
Okay,
sir.
sir.
Thank you, sir.
Thank you, sir.
All right.
Thank you, sir.
Thank you, sir.
Thank you, sir.
See you.
Thank you,
Bye.
sir.
Bye.
Bye.
Thank you, sir.
Bye.
Thank you, sir.